Today's lame cow focus is on the M of lame cow. We've already gone through the L and the A, so just a quick review, and then we'll get going on the M. We know L is thinking about latitude, the idea that the Earth has uneven heating due to those direct and indirect rays the Earth gets from being tilted. And then within air pressure, we focused on high and low pressure systems and all the characteristics with it. So hopefully you're now watching this video because you did a little review on each one of those and are ready to move on to our M, mountain barriers. For our climate factor M, we have to remember that we're thinking of things that can affect both temperature and precipitation. And mountain barriers actually do both for a climate. Mountains are big enough that they actually can direct air masses. So they can actually force air up or force it down, around, drive it, creating something known as a rain shadow. And so a rain shadow, you can maybe guess by the name, is creating an area around a mountain range without rain. It's like a shadow cast where rain doesn't come. And you can see that a little bit from the diagram too. What's going on with this mountain barriers is we end up with two distinct sides of the mountain. One known as the Mediterranean or the wet side of the mountain, and one known as the desert or the dry side of the mountain. So mountain barriers is forcing air a certain direction to create what is known as a rain shadow, giving one side a dry desert-like climate and one side a wet Mediterranean type climate. A great natural example to think about is the Sierra Nevada mountains. Here's the Google image of the Sierra Nevada mountains, so you can kind of see the busy part of the map is where all the mountain range is. And you can see that a little bit clearer on your diagram as well. But let's just make those mountains stand out a little bit more. So just go ahead on your sheet and accentuate the mountain range a little bit. And then you maybe recall that the wind is coming off this Pacific Ocean and the California coastline. So as that wind approaches the mountain range, like we said, the mountains force the air up and around, creating two separate climates. One is the rain shadow, and that ends up on the Nevada side in this example. And over here is my wet, more Mediterranean climate. And again, we can kind of see that in the Google image. Over here, I see it more green. That's indicating I get a lot more rain on this side of the mountain range. Whereas here, this is more dry and desert-like, giving me that climate for the rain shadow on the opposing side. So make sure you have a couple labels happening on your picture there to show off that example. So remember, each of these climate factors comes with two sides. One side is getting to know what the effect is, and the other side is getting to know, well, why or how does this happen? So to understand that, we've got to do a quick little review here of what air molecules are doing in different temperatures. This is, of course, the warm temperature air. And then over here, we have the cool temperature air. Okay, the molecules in each one move a little bit differently. Here we can see the warm molecules have a little bit more energy within them because they're moving at a faster pace. We can see their little motion lines here are a little bit bigger, giving the illusion that they're moving a little bit faster. Whereas cooler temperature air, the molecules are a little bit more tightly packed together, so they have less energy or lower levels of energy, and that's because they're more tightly packed and they are moving slower. I wish I could show you a little animation of this, but if you just do a little Google motion of warm versus cool air, you'll get a little bit of video showing how fast these molecules are actually bouncing around in the warm air, Whereas the air cools down, it slows down, and it actually has less and less energy being used. Okay. Now, one little side note about each of these as well is that cooler air can hold less water vapor because it's got less energy. It's not strong enough to hold up more molecules within it, where the warm air over here can actually hold more water vapor. Again, notice there's a little bit more space in between all these molecules. They're moving a little bit faster, so they have more energy and therefore more room or more space to hold H2O. So warm, just a little side note to add there to the review on the right hand side. Warm air holds more moisture while cool air holds less moisture. So jot that down on the right hand side as well. So as we think about what's happening with the motion of those different temperature airs, we can then connect it to what's going on to make this rain shadow. So what we see in our picture is that first thing we have going on is this warm air coming in from typically an ocean. So warm air comes in, it hits that mountain area, and it has to go up. So the mountain barrier forces the air upwards. And as it does that, it rises up and cools. And reminder that cool air holds less water. So all that moisture trapped in the air over here is actually squeezed out. And so here we can see a little cloud and rain coming down. Squeezed out on this side, giving it a much more lush type of environment. Now that that air is empty and it peaks over the mountain, it's forced back down and it starts to warm up, spreading those molecules back out again and becoming drier now that all that water has been released. So as that air goes up and over the mountain, the temperature goes down, releases a lot of that moisture, leaving it behind on one side, and then as that air flips over the top of the mountain and starts to sink back down, it warms up and is very dry because of releasing all the moisture on the other side. This over here then is known as the rain shadow. A lack of rain on one side of the mountains. So you have this picture to draw in on your notes page. There's a couple key words that we want to make sure we get labeled as we draw them in. We want to draw in some rising arrows and sinking arrows showing what the air will do as it approaches the mountain. We want to label where the wet side is, where the dry side is, and then show where the rain is pouring out as well. At the bottom, we're going to give names to each side. One side of the mountain is known as the windward side and one as the leeward side. So again, kind of like that diagram that we just saw, we know that the air works its way towards the mountain, and at this point it has to go up. And so we're going to label that as the rising air. So I'm going to first put in an arrow showing it going towards the mountain and then rising up, and I want to label that as the rising air. So I can check that off my list on the right. Now we also know that air is a little bit warmer. So notice how I used red. You could go ahead and color code your arrows as well. As it reaches the peak of the mountain, it comes back downwards. That's where we're going to get our sinking air labeled. And we know that as it comes back down, it also cools. So I'm going to switch to blue and give this a label of sinking air and a little bit cooler. Now as that warm air rises upward, you may recall it starts to cool down and lose the moisture it was holding previously. So one of the things we want to draw in is a cloud and some rain showing the location where the moisture is being released. That is on this side, allowing many more plants to grow from the moisture released on this side. This is the wet side of the mountain. You can check that off. We're over here. This is the dry side of the mountain. I tried to add in a little cactus. You can go ahead and label this as the desert side, again known as the rain shadow, the side of the mountain lacking the rain. So each side of the mountain is known as a certain term. Over here we know this as the windward side. Its name comes from the side of the mountain where the wind is approaching. And then over here, this is the leeward side, the side that is the desert or the rain shadow. Those are two pretty important vocabs. We want to get to know the location and also the air motion and moisture content, dry or wet. So just go ahead and pause and make sure your diagram has everything labeled and is set to go. So a couple in conclusion questions down there at the bottom. Which side of the mountain receives the least amount of rain? Looking at your diagram, go ahead and circle up, or I guess write in your choice, either windward or leeward, and then hit me up with a little because. Why is it that that side gets the lowest amount of rain? What happens to all the moisture being carried in by the wind? Why is it gone? And where did it end up? So here's a pretty cool image from Google Earth. We can see this island here clearly has a windward and a leeward side, and we can tell pretty clear the border between the two. This is my mountain range right in here. So looking at the picture, see if you can figure out which way the wind is coming from, which side is going to be the windward, and which side is going to be the leeward. And what I'd like you to do is down there at the bottom where you have the two choices, where it says windward and leeward, just go ahead and put a little R next to the one on the right and an L next to the one on the left. So right down here, if the windward is the right side, put an R. If it's the left side, put a left or an L. And then the same thing down here. Leeward, what side is it? Is it the right or is it the left? So just give a little label down there and we'll kind of look at this together next class. So again, remember going back to how does this affect climate? We're thinking of two factors. How does this idea of rain shadow change the temperature on each side of the mountain? And also how does it change precip on each side of the mountain? So again, we have two sides, windward and leeward. Windward is known as the side where the wind comes in, and because the air is being pushed up, that's also side where it is wettest. And we can see here windward is our side with the cloud and the rain. Right? This side tends to be a little bit cooler as the air rises up and cools down from being forced up and around the mountain. The leeward side then is the dry or desert-like side. It's got high pressure pushing that air, or as that air pushes back down. So remember our little saying, high and dry, right? And that also tends to be the little bit warmer side as well, where I get that desert rain shadow environment. So big picture, mountain barriers can create their own high and low air pressure by forcing the air up and over the mountain. We get low pressure on the windward side, creating a lot of moisture, and we get high and dry on the leeward side, lacking rain and a little bit warmer. You have a few summary questions to answer, so double check which ones relate to the M and get those completed.